So he is here as a guest faculty for the GYAN program. So in his, he is by profession is agricultural engineering. So he is doing a lot of work with the food engineering aspect of in his department. So he came here, first he has done, given the information regarding the rheology. That is how the fluid food, just like juices and honey, then milk, what is the behavior when you change the shear rate. So after the rheology part is over with the GYAN participant. So now we will be talking about the MATLAB application basically in rheology, mainly in the rheology, especially when the food flows through a pipe. Okay, and any liquid water or the food flows through a pipe. So how it behaves? This is very important for us because the food they contain all nutrients, and once the food contains nutrients, the microorganisms can grow in them. When the microorganisms grow, there are a lot of safety issues are there. So in his basically this training program, he will be addressing this issue that how the food behaves when it flows through a pipe, and secondly, what are the various quality and food safety issues related to that. So please welcome Dr. Donald.
Thank you, Dr. Sobi. Nice to have some other students as well. So I'm glad to be here. I'm honored to be here. And just not everybody was at the morning session. So I'm going to be teaching out of this book, which MathWorks recommends. And so I have the slides I have come out of this book. They prepared it. MathWorks had it prepared from Duke University. And I believe Dr. Sobi has already sent a link to the people who are attendees for the program. So you have a link to my Google Drive. And on the Google Drive, you can download the slides. You can download them now. If you can get on the internet, you can download them right now. In fact, when I teach the course, some of my students, they have the slides on their computer and they type in notes on the slides. So that's why I kept it as a PowerPoint, if you want to do that. Okay, so you have everything. You have all my code as well. Okay, and so a little introduction to MATLAB. I don't know why it's back and forth, but anyway, the way it looks is that you have the command window. The command window is right here, and this is where we're going to put our commands. The command window is only for short lines, 2, 3, 4, 5 lines. If we have many lines of code, like 20, 30, then we'll make up a file. And I'll show you that. We have and then we have a separate code file, an M file. And then over there is the workspace. The workspace tells you what, all the variables that you define. It tells you the value. Over there is the command history. It tells you everything you put in there. All your history commands. And then over here, I will show you, this tells you where you are. It tells you a directory. And then this one is just details. Okay, so we'll be working on that. I'm going to do the chapter 3. So the chapter 3 gives you the introduction. It just gives some examples so that you feel familiar with MATLAB. Okay? How many people here have already coded in MATLAB? Please raise your hand. Just one? Okay, then this is very good for you because it's beginning, all right? That's fine. Okay, so I'm going to start working through the slides. All right, so we're going to talk about what is an M file and how to incorporate. So this will tell you how to use the files and what are functions. All right? And then we'll talk about some if and else, some other different kinds of. And I'll tell you how to write functions. Okay? So in MATLAB, there are only 2 kinds of files. One is a script file, and the other is a function file. Everything is run from the script, and the script accesses the function file. Just 2. So that they describe here. So you can run the script and you can do a debug. It's just, so the reason we have a script file is because we have many lines and we need to save them. If you only have 2 lines, you can just put in the command. Function files are different. The function receives input arguments and outputs a result. So here's the function. So this is how all the functions are written. So the function has an output. An output comes first. It equals the function name, and then you have the argument list like x or time. And then under that, you put your statements. So whatever the function name is, whatever. I don't know why this goes like this. Okay, so whatever, when you write a function, you have a function name. Whatever that name is, it can be anything. Whatever it is, it has to appear somewhere up here. So that func name has to appear. Hello. Let me say again, let's go. So the function name is how you refer to it. Hello. But if you want an output, you have to have an output there, and then the output has to appear in one place. And it says output equals this. And then whenever you call the function, it will always output this, which is right at the top. So if your output is y, then you have a statement there that'll say y equals 2x plus 3, and that's what you get. Okay?
And again?
Okay, so here's an example function. You can see the name is freefallVel for velocity. The percentage is just comments. So they don't mean anything. The computer ignores anything with a percentage in front. That's free. That's for a person to read. And then you go all the way to the bottom and it has G and V. You notice the V is at the top and the V is at the bottom because it's an output. So the output is V. Okay, so let's do it. So I'm going to copy this function. And by the way, you feel free to write this in. You can do it yourself on your screen. So I'm copying it. And remember, the only thing that the computer looks at is the G and the V. It ignores everything above it. It only looks at function, the G and the V, because everything else has a percentage sign. So if I paste it in, so watch what happens. I got an error, so what is that? Okay. Hang on a second. I know what it is. I just forgot to put this in. You have to access like this. So what we're going to do. Okay, now I'm going to show you your first lesson in MATLAB. The first thing we have to do is show where the directory is. So you go up here, and you go find your directory. Not letting me find the directory. Hang on. How come it's not producing my directory? All right, yeah, thanks. So it's up here.
फोन करा दे माइक
Okay, so this app.
दूसरे माइक वन चला कदम ਉਹ ਸੇ ਚੀਜ਼ ਦਾ ਬਟਨ ਔਨ ਕਰ ਦੇਣਾ ਤੇ ਮਾਈਕ ਉਹਨਾਂ ਦਾ ਬੰਦ ਹੋ ਜਾਂਦਾ ਪਿੱਛੇ ਹੋ ਗਿਆ ਪਿਛਲੀ ਸਾਈਡ
into a file. Okay, hopefully everybody sees what we're doing. And one, yeah. Okay, good. There you go. Okay. So now, yeah, thank you. Thank you for the help. And now you can see I have all my files here. Files right here. There should be, look, there are many MATLAB files.
Only HTML is being opened.
Okay. Okay, so hopefully everybody sees that, right? So what I did is identified a folder in my directory. Now we're going to open up the function which is called freefallVal. So it's write freefallVal, and I've already written this. So there's my file. So if you want to see how to do this, what do you do? The way you create this file is you go File, New, and then you go Function, like that. Okay, and then since I've already written it, it's helping you right here. Okay, but what you do is you just write your function in here, and that's what I did. Okay, so that's how you create new function. Okay? File, new function. All right, so now. Let's see, I don't want this, I want to do CLC. Okay, so I have free fall velocity is already written, you see it's sitting here, right? This is just if I want to do it. Okay, so free fall velocity. Okay, now the free fall velocity is asking for T, M, and CD, and it's outputting V. So to call it, I go here, and I'm going to copy this, paste it in into the command window. So, and then it should run. So there you go. I give 8/100.25 and I get the answer. So that's the answer for the velocity, free fall velocity, if I give those inputs. And the inputs are time, mass, and a drag coefficient. Okay? And then it gives you 53 meters per second. Okay? Well, that might be miles per hour. I have to check. No, it's meters per second. All right. Next, so let's keep going. If you have any questions, you can ask me. Okay? Yeah. Yeah, so the reason we're doing this is to show you how to make functions. It's true that you can do this in the command window, but most of the time our functions are longer than this. So when you have a function that's long, you don't want to do it in the command window. You want to put it into a file. Usually it could be 100, 200, or 500 lines long. That's fine. This is just an example to show you what to do, okay? And then you can put in help. If you do a help, it'll show you help free fall velocity. Okay, and then it tells you what the variables are. Another thing that I like to do when I start is I don't like having double spaces because when I have double spaces, it takes up a lot of room. So I change it. now everything becomes single space, and it's easier for me to read, and I don't have to keep scrolling. Okay, let's keep going. If you want to look, you can put look for, and it tells you, it'll look for everything that has a name in the bungee. So if you do this, so it looks for everything that has the word bungee on my directory. And it tells you. That way, if you have a lot of files that have the same word, you can find them like that. Okay, let's keep going. Okay. All right, if you have more than one output, then you put them in brackets. So this is called stats. Okay, so and I want to output the mean and the standard deviation. So if we find stats, I have it pre-written, right? You remember you do file, new, function, and you can write it, right? I've already done that. So I'm just going stats. You can see the stats requires an X, and it gives a mean and a standard deviation, right? And then I go to the command window, and I do, I'm going to have right. Okay, so I'm going to create a y vector, and then I'm going to call it. So I create my y, I create my y vector like this, and then I call the stats, okay, and it gives me the mean and the standard deviation. All right, so that shows you that if you want to have more than one output, you can do it. And you still get the same inputs, but you have to put a bracket for more than one output. All right, next. Okay, so now we come into sub-functions. And the sub-function means you can have a primary function and then a sub-function inside the function. Now remember, when you have a sub-function, then you cannot see it outside the function. That means the script cannot see it. So the script sees only the primary function, and the primary function can see the sub-function. So I'll show you an example. So here we have a function called free-fall sub-func, and the inputs are the TMCD, and then the output is V, and then there's an end here, but underneath it, it has a sub-function called VEL right here. VEL is a sub-function. Yeah, that's wrong. That's wrong. It's not V, it's VEL. I don't know why they did that. Okay, that's an error. It should be VEL as a sub-function. Yeah, it should be VEL. Yeah. And so you have G, and then it defines the V. Okay, and so what happens is, I'll show you the next one. So I'm going to call free-fall. So I'm going to call free-fall sub-func. Okay, so the answer is still 50.6 with a velocity, but I want you to see the difference. So the difference is, okay, so let me show you what's happening here. So this is a function. The free-fall sub-func is the function. The vel is the sub-function. So the free-fall sub-func calls the vel, and the script cannot see. When I say the script, I mean the script or the command window, either one. We're using the command window. So the command window cannot see the VEL. The free-fall subphone can see the VEL. So it calls the VEL, and it sends in the TMCD from there. It sends it in here. It calculates the V here. The V is an output, so the output goes here. And it turns out that the V here is also an output. But remember, the VEL cannot be seen, so I can prove that by showing it to you. So you see that it's undefined function, right? Because the command window doesn't know VEL. It's not there. Does everybody see on the right side, you see the workspace? See the workspace that is answer MSY, all the way to the right. There's no VEL because it cannot see the VEL. It sees all the others. Any questions?
Sir, what is CD here? CD.
So CD is the coefficient of drag. So it should be, well, if it was in one, if it was down here, it was this one. CD, second order drag coefficient. Okay? And next. Okay, how do you get, well, if you want to ask for input, then you can use n equals input prompt string. I'll give you an example. It's coming up. So if you want to input the mask, then you do it like this. So what will happen is the program will ask you for the mask. Okay? So you put in 22. And then, okay, here's another one. Right? So same thing. If you put in your name, if you say what is your name, and then you put an S, it will wait for your name. So that's how you get input. I mean, if you want to have input where you wait, you can use that. Okay, output. Now, output you can use display. So here's an example. So the same, we have a function called freefall_i, and then you have your input, and then you have your display. And so you can display velocity, and then you can display this entire function. Let's try that. So I will find freefall_i. So I've already pre-written this. Okay, and then I'm going to call the function. And I will run it. This is how you run one way to run a function. So if I do run freefall_i, so it asks me for the mass, and asks me drag coefficient. I can't remember what it was. I can't remember. And then the time, so the time was whatever, 15, whatever it was. Something happened, 80 at freefall. So now you can go to the line number 13. Oh, I have some weird script there. Okay, hold on. That's just, I was trying something different. So what I'm going to do is, here's what you can do. If you want to comment the lines, you select the lines, you do a right click, and you put a comment. So then it becomes a comment, but I think, yeah, that should work. Yeah, I think that'll work. So then I save it, and then run it again. So I can push my arrow. Here's my arrow. Okay, maybe it's an old version of MATLAB. Strange. It should have shown me the free fall. So I'm going to go over here, and you can click on free fall, and it runs. 22, 60, or whatever I put in, 60, time. Okay, now it gives the velocity. Okay, so did everybody follow that? Right, so all I did was I just ran free fall high. I found an error and I went to my code and then I took a certain portion of the code and made it commented so that it ignores it. Okay? Alright, this one, if you want to format your output, you can do that. So you have to use fprintf, you put in the format, and then you put in the various values you want. And then the way that you do the format is you determine whether you want an integer or other kind. And there are different ways, so I'll give you an example. So if you want to print out your velocity as 8 digits total, so 8 places total, and you want 4 decimal digits. You want 4 decimal digits, then it will print like this. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let me do that. I have to define velocity. Hang on a second. Let me check my workspace. So my workspace has. Now let's try it again. Okay. So did everybody see that when I push the arrow key, it brings up my history? You can see, right? I'm pushing the arrow keys, and it brings up my history. So there's my history. I run it again. There you go. And then it should be 8. So I have 4 here, 5, 6, 7, 8. You may be disregarding the decimal. I'm not sure. But it looks like there's a space. And then, yeah, so it should be 8 right here. And then 4 decimal digits. Right? So now we'll look, how does MATLAB access files? Right? How does it do that? So there are different ways. Let's see, I'll show you. So first of all, let's look at, okay, they do have something called MATLAB files, and we call them .mat. So let's create, let's see, all right. So if I don't specify what kind of file, it automatically does MATLAB. So I do a save, belt drag, BCD. Now, let's look back up here. I've got B. I've got CD, right? So the way that you save it is you give a file name, and then you put the variables after that. Okay? So if you don't put the variable names, it saves everything. So I'm going to save it with a file name named belt drag. So let me go to MATLAB. Yeah, see, I already have it there because I did it before, so I'm going to delete that. So you'll see it's gone. Okay, I just deleted it from my workspace. And now let's try running it. So let's go here. I'm going to do this one. Okay, let's run this. Okay, does everybody see that the belt drag right here was just created? It wasn't there before. So you can see that I saved belt drag and it has V and CD in it. Okay, so that's one way to save it. I'm going to go back here. Now I'm going to clear it and then ask for V to show you that it's not in my workspace. If you go, so let's do clear. Okay, does everybody see my workspace disappeared? So I cleared my workspace over there, right? But I saved the V inside belt drag. So if I do V, it says I don't see it, right? So what we're going to do is load belt drag. Now take a look at my workspace. Watch what happens. Everybody saw the workspace? Now I have CD and V because I loaded belt drag. So that's one way to save your Mac files. All right, and then I can do the V. So there it is. It was saved in a Mac file. So you can save your Mac files. Okay, sometimes you want to do ASCII files. So if you do ASCII, you need to put the name ASCII on the end. Okay, so I'll show you an example. Now, if you do A equals this vector, and then I save it with the name matrix.text, and then I use these ASCII codes here, and then you can reload it. So you have to put ASCII. Yeah, you need to put a dash ASCII, okay? So let's try that. Okay, so now let's find synth-matrix.text. So synth-matrix.text is right there. Does everybody see that it's a text file? You see that right there? It's not a MATLAB. It's a text file, okay? And then I can load it. So when I load it, it appears right here, synth matrix. So if I open synth matrix, you see, I can see the matrix that I just created. And I'm going back and forth. When you have it up here, you can do this editor. Do what happened to the go back to my command. Oh, okay. Okay, yeah. Okay, so you can always look at anything over here by clicking. You can look at your data, your workspace here. Okay, and then I can close it and go right back to the command window. All right. Okay, so we already did the text file. And now X file. Excel files. So I want you to follow this because I do a lot of work with Excel files, depending on what you prefer. You might like text, but a lot of people share data with Excel files. So I like to read data from Excel, and then I also print data into Excel files. So let me show you how to do that. It's very useful. Okay, you use XLS read for reading your Excel. And then you use XLS write if you want to write it into a sheet. If it doesn't exist, it will create it. So I'll give you an example. Alright, so I'm reading from one Excel file, I'm doing some computation and writing to another Excel file. So first I want to show you my VelDat file so you can see what I'm reading. So VelDat is right here. I'm going to open it so you can see it. Velocity data, and now you see I've got my times in the first column and I have my velocities in the second column. Okay? So let me close this. Go back to the reading. So I'm going to read that file into data. I'm going to take the first column. So you see that when you have a colon, it means everything. So it means read all the rows, first column. And then that will be time. And then you do the same thing for velocity, but you read all the rows, second column. And then I just put all the time into vel time. So I put the time in the first column of vel time, and I put the velocity into the second column of vel time, and then I have a column header because I'm going to send it to Excel. And when you do a header with the words in it, you need these curly brackets on both sides. Now I'm ready to write it to a new Excel sheet. So I'm calling the sheet results Excel S, should be X, okay? That's old Excel, all right. It should be Excel S X because that's after 2010. Okay, so I'm going to name the sheet results. I'm going to send my column header into sheet number 1, and it's going to start on cell A1. And that's my header, just my column header.